In this video, we are going to talk about implicit differentiation. So what does that mean? For example, the equation of a circle, a circumference with center 0, 0 and radius 1 is given by x squared plus y squared equal 1. Okay, so that is the circumference of radius 1. Now, if we wanted to compute the tangent at any given point x0, y0, so that can be difficult. Okay, let's say we want to compute it here at this point, for example. Why is this difficult? Because first thing, we need to write y as a function of x. Then the tangent is going to be f prime of x0 times x minus x0 plus y0. You don't believe me? Try it out. So you see that here we have two challenges. The first one is that we need to find the function f of x. Okay, so we have to solve for y in the original equation. The second challenge is that whatever we get, we need to take the derivative, and that may not be easy. So let's do that. So in this case, we have y squared equals 1 minus x squared, all right? And when I take out the square, then I'm presented with two options, the plus and the minus square root. Now, we are going to select the plus square root if we are interested in a point that is in the positive y's. Okay, if we are interested in the negative y's, we will take the negative square root. But then once I have the square root, then this is my f of x that I was looking for, and then I need to compute the derivative, which is the derivative of the square root, the chain rule, right? So it's 1 minus x squared inside, and then the derivative of what is inside, which is negative 2x. There is a bit of cancellation, but this is not looking very easy. So the conclusion here is it gets a little messy. So if we want, we can write the whole thing. So this would be minus x0 divided by square root of 1 minus x0 squared times x minus x0 plus y0, which is the square root of 1 minus x0 squared. This is the y0, which is f of x0. And this, you give me a point, this will give you the tangent. But it's not easy. I hope I convince you about that. There is a second way. There is an alternative way to do this. So when we look at the formula, let me state here that now we are going to see an alternative way. So we have the formula x squared plus y squared equal 1. Okay, and this defines y as a function of x implicitly. Okay, so we write it like this. You give me a value of x, we can plug it in here, I can solve for y. So for every x, we get a y, so that defines a function, but it's defined implicitly because we need to solve for the value of y. If I write y equals square root of 1 minus x squared, this defines y as a function of x explicitly. Okay, here there is nothing to solve for. It's already written. Y equals, boom. All right. So the magic here, the implicit differentiation, says that we don't always need to compute the explicit formula for f of x. We don't always need to solve for y if all we want is to find the derivative of y. Okay, so implicit differentiation. The magic here is that we don't need to solve for y equals f of x if all we want is to compute dy dx. Okay, so how is that possible? All right, so let's do the same example. Let's finish it, and then we move on to something more complicated. So here, what we are going to do, because this is an equality, we are going to differentiate both sides respect to x. Okay, the right-hand side is easy because that one is a constant, the derivative is 0, so that one is done. And on the left, we have a sum, so we have that this is the derivative of x squared plus the derivative respect to x of y squared. And here comes the new thing. Here we assume that y is a function of x. Okay, so then here what we have is a composition of two functions. We have y of x and then a squared. Okay, so let's take the derivative. The derivative of x squared respect to x, that one is easy, is 2x. The derivative of y squared by the chain rule, first we take the derivative of the outside function, which is the square power. So that's 2 multiplied by y, because we need to multiply by the basis, okay? This is the chain rule. And then by the chain rule, we need to multiply by the derivative of what is inside. Inside we have dy, which is a function of x. We are assuming it's a function of x, so dy dx. Okay. This is where most people get puzzled, okay? We need to remember x is just the variable we are using to take the derivative, so no problem, that's the usual thing we do. But y, we are assuming it's a function of x, so we need to treat it as such, okay? Imagine you were writing f of x squared, okay? How would you take the derivative of this? And now here, what did we find? We found 2x plus 2y times the derivative equals 0. So this means we can cancel these two 2's. So this is dy dx equals minus x divided by y. And that's it. Here we have a very simple expression for dy dx that involves both x and y. But this was very simple. Did you notice it was much simpler to solve for dy dx than it was before to solve for y? So here, for example, I could, if I want to find y prime of x0, okay, that's at the point x0, y0, what I'm going to get from this formula is minus x0 divided by y0. Okay, so then much easier. We can just finish our formula for the tangent, y minus y0 equals the derivative, which is minus x0 divided by y0 times x minus x0. Of course, this is not going to work unless y0 is not 0, okay? But that's, if y0 equals 0, let's go back to the picture, then we would be in this at this point, and here the tangent is clear, it's vertical. So we can say, well, in that case, the tangent is x equals 1, okay? So that's not a problem. Let's do more examples. Let's say now I give you something very similar. 3x squared plus y squared equal 4. And here we want to find the tangent at the point 1, 1. Okay, so first thing, this is what we want to find. So first thing we need to always do is to check that 1, 1 is in the curve, okay? Because it's a question. There we go. So then we just need to check 3 times 1 squared plus 1 squared equals 4. It does, so it checks out, no problem. Always check this just in case the problem is not the statement is incorrect. That can happen. Now, once that's checked, so we need to find the slope. Okay, that's our dy dx at x0 y0 now is 1 1. So we do the trick of implicit differentiation. So d dx 3x squared plus y squared equals d dx 4, which is 0. Okay, so here we have 6x plus 2y dy dx equals 0. Here, if we want to make it easier, we can substitute already the point. Okay, so that we don't have to, the algebra will get simpler. So this would be minus 6 times 1 plus 2 times 1 dy dx equals 0. Okay, so we have here dy dx, that is 6 divided by 2, that makes 3. So the slope is 3. Now, once we have that, we have here 3 times x minus x0 plus y0, which is 1. And this is the 3x minus 2. This is the tangent. You saw that it was not a big deal. Now, geometrically, what is this object here? 3x squared plus y squared equal 4. So this looks a lot like the circle, right? The only thing is that we have different numbers here in the coefficients. So when that happens, we have an ellipse. Remember the formula for the ellipse? And if you don't remember, it's a good time to learn it because we will use this once in a while. The formula for the ellipse is x divided by a to the power 2 plus y divided by b to the power 2 equal 1. And here a and b are the lengths of the axis. Okay, so here we have our a and here we have our b. Okay, So notice that if A and B are equal, then we have a circle of radius, whatever number they are equal to, okay? So this is an ellipse. This is the equation of the ellipse. And I'm saying this because here, it's not exactly that of that form, but we can make it look like that. So we can divide by 4, right? So that we get a 1 on the right. And here we can do x squared divided by 4 divided by 3 plus y squared divided by 4. But we can actually write this already as a square. And then here, with a trick, we can do the same thing. So this is 2 divided by a square root of 3, all of it to the power 2. So this means that our ellipse actually is not going to look horizontal, it's going to look vertical. That doesn't look like an ellipse at all. There we go. It's going to look something like this. And we are going to have the y-axis that is 2 units long, and then the x-axis that is 2 divided by a square root of 3 units long. And our tangent is going to be somewhere around here. Okay, this will be the point. 1, 1. Yes, that was correct. And this is what we did.